Hey, this is just a quick lecture over how to calculate some information with the independent samples test. I'm going to go over pooled variance, and I'm going to go over how to calculate the test statistic and also how to calculate uh, the f-test to determine the homogeneity of variances. So I'm going to go ahead and share my screen. And share screen three. Let's see here. So I'm gonna make this available to you as well. But let's see here. Collaborating. Um, we've got a few things here. First of all, we've got, and I'm going to upload this, but we've got movie ratings for animation movies versus movie ratings for comedy movies. And we want to know, are the variances, what is the variances with both of these? So what we're going to do is we're going to, first of all, calculate the pooled variance with summary data. Sometimes you have raw data, but sometimes you have summary data. And so a lot of times, let's do data analysis, and we're going to go in and we're going to get descriptive statistics. So when we get descriptive statistics, we're going to highlight all of this data, and I highlighted with column D first, going all the way down because there's a lot more. Um, and so it's grouped by column, label in the first row. Then for the output range, let's go up here, descriptive statistics, summary statistics, confidence level. There we go. And so we've got all the summary statistics right here. And there's a few summary statistics in here that we need to use in order to calculate the pooled variance. Notice this right here, N1 stands for sample size of sample one. So that's right there. Okay. And then N2 is sample size of the second one. And then we've got the standard, or sorry, the variance for sample one and the variance for sample two. And so we're going to highlight that variance and variance. And then we can calculate the pooled variance by just by having the summary data. And this is a little bit cumbersome, but we can go ahead and do this, and we're going to do equals and put those parentheses in, and we're going to do n minus 1. In other words, this we're doing the degrees of freedom for the first sample. So n minus 1 multiplied by the sample variance for the first variable, and then we're going to add it to uh in parentheses the second sample size minus 1 um multiplied by, make sure that you get those multiplied bys, the variance for the second sample. Okay. And what we have right here is the this top numerator portion. Okay. But we're not done yet because we've got to divide it. Okay. And so you can divide it in this right here by just putting parentheses around it. Um, and then doing divide by. And then we, once again, in parentheses, sample size 1 plus sample size 2 minus 2. Okay. And so essentially what you've got is the degrees of freedom divided by the degrees of freedom for both samples together. So we took the numerator divided by the degrees of freedom for both of them together, and that gives you the pooled variance with summary data. Okay. The other thing that you can do is use the data analysis tool. So let's do data analysis, and we're going to do t-test assuming equal variances. It will not give it to you with unequal variances. There's actually a completely different formula, which I wish it would give it to you because it's going to give you a slightly different piece of information. But we're going to use the t-test two samples assuming equal variances, and we're going to press OK. And I'm going to highlight variable 1. and I'm going to highlight variable 2. And then the hypothesized mean difference is 0, labels in the first row, and where do we want this to go? Let's see here. We want it to go t-test, assuming equal variances, and we're going to put it right there. And this gives us our pooled variance. Now, really important, this is the pooled variance, which you notice pooled variance is right there. This is the pooled variance, same exact thing, but you're eventually going to need the pooled standard deviation. In order to get the pooled standard deviation, you do equals the pooled variance divided by, or sorry, square root of the pooled variance gives you the pooled standard deviation. Okay. So that's how you get the pooled variance with the data analysis tool. The next thing that I want to go over is testing for the homogeneity of variances. Now, homogeneity of variances is saying, hey, we've got the variance for sample 1 and we've got the variance for sample 2. The variance for sample 1, is it similar to the variance of sample 2? Well, in order to check to see if they're similar enough to compare them, we need to run a test. And so there's a few ways that we can do it. We can do it with summary data. So if we have summary data like this, okay, what we're going to do is we are going to do equals sample variance 1 divided by sample variance 2, and this gives us our F statistic, or F calc, if you will. Okay. And so the way that we determine the probability of these variances being similar enough is we are going to use one of these two formulas. It's going to be f dot dist or 1 minus f dot dist. If variance 1 is smaller than variance 2, we're going to do this right here. Actually, I think I've got that switched. Let's see here. So equals, so we're going to do probability. So equals f dot dist, and then we're going to do the f value, and then we're going to do the degrees of freedom for sample 1. So that's 311. And then we are going to do the degrees of freedom for sample 2, which is 3018. And then we are going to do true. Okay. And notice it gives me 0.86. And that's what I was saying is I had these switched. There we go. And so what we needed to do is because this variance was larger than this variance, we're going to do 1 minus. And so it gives me the 0.13. Okay, so that's 0.13 for the F test. So that is the probability of getting it. So we want to compare that to 0.05. If P is less than 0.05, run the unequal variance test because it violates the assumption of homogeneity of variances. Okay. Let's home merge wrap. And I know that I spelled, there we go. But this is greater than 0.05, so it didn't violate it, so we're fine. The other way to do this, once again, data analysis. If you've got raw data, you can come up here and do F test, 2 samples for variances, and highlight movie ratings, then do it again. Movie ratings with an alpha of 0.05, output range. Let's put the output range right there for the F test, and then press OK. And once again, it gives me F of 0.109, it gives me the p-value of 0.13, just like what we had right here. And because this is not less than 0.05, we do not violate that assumption. In other words, these variances are similar enough that we can compare sample one to sample two. If it was less than 0.05, we would be running something else. So, and I'll show you that in just a minute. Now we need to calculate the test statistic. Okay. And the way that we calculate the test statistic, just like we've been doing, you take the sampling error divided by the standard error, except it's slightly different now. Okay. And you can do this with summary data. So we take the mean of sample one minus the mean of sample two divided by the standard error, or in this case, the pooled standard error. So uh, let's do that really quick. Equals the mean of sample one. Let's see here, mean of sample one minus the mean of sample two, and this is essentially our sampling error. Okay, and then now we're going to do our standard error, or in this case, our pooled standard error. Okay, and we're going to do equals square root of variance 1 divided by the size of the sample, or count, plus variance 2 divided by the count. And so now we have our pooled standard error. Let's home wrap text. Oops. There we go. Pooled standard error. And then you do equals sampling error divided by pooled standard error. And this gives you your Z value, or in this case, it would actually be a T value because we don't have, it's the same exact formula. It's just one is a T and the other one is a Z. The Z would be, what's that called? If you have the population standard deviation, then you would have that right there. Okay, but we've got samples. So there we go. We've got the right here. This is the T calculated value that we calculated by hand with summary data. Okay, but if you have raw data like this, then you can use the data analysis tool, data analysis, and we are going to use two samples assuming equal variances. You would use unequal variances if your f p-value is less than 0.05. But it's not. We have a p-value of greater than 0.05, so we're going to use equal variances. And we're going to do okay, and we already did this once. So, once again, movie rating all the way down, movie rating all the way down, and then output range right there. Hypothesized mean difference is 0. Okay. And we've got sorry, we've got the T statistic, we've got the p-value, so on and so forth. Now it's important to note that the formula that I showed you with the T-calc and the Z-calc, okay, I added just a little bit to this to clarify. The Z-calc, you have the sampling error minus, you've got the sampling error divided by the standard error, sampling error divided by the standard error. This right here, this T calculation is for when you have unequal variances. But when you have equal variances, in other words, what we have right here, so we have, this compared to this, and they are equal enough that we're like, hey, they are equal variances. We can compare them, they're apples to apples. So this is when you're comparing apples to oranges, this is when you're comparing apples to apples. And so we can take, once again, the sampling error divided by the standard error, but we're calculating the standard error slightly differently when the variances are the same. So these variances are different, these variances are the same. And so pooled standard error uh when uh unequal variances. Okay. And then let's do pooled standard error with equal variances. Okay, so we've got equals square root the right here, these pooled variance. So we take the pooled variance that we got up here, 301. Okay, and then we are going to multiply it by 1 over the sample size for sample 1 plus 1 over the sample size for sample 2. And that's going to give us the pooled standard error when the variances are equal, which you notice these are just slightly different. So um, let's do this. Home screen. Okay, and so we're going to do tcalc, which is going to be slightly different, and we're going to do equals sampling error divided by the pooled standard error with equal variances, and it's going to give us a slightly different answer. And notice right here, um, this is assuming equal variances. The pooled variance, you've got that right here. You've got the t statistic, and the t statistic, let's see here, paste values are the exact same. And so this is the formula for the equal. This right here is the formula for the unequal, and this right here is the formula to do it when you have the population standard deviation. And then once again, if you have the raw data, which I normally give you guys the raw data in this class, you can do it like this. So that is how you do this. I'm going to save all both of these documents, and I'll save a blank one for you too, so you can work through it yourself. But hopefully this will be beneficial to you as you are going through it.